everyone, welcome to today's webinar, Design and Detailing of Timber Structure with Cype. My name is Chiming and I'm Country Manager for Cype Software, and here is our civil engineer, Afonso. Hi Afonso, how are you doing?
Hello, Shimin. How are you? Yeah, very excited. Let's do it. It's going to be a very nice topic for today.
Good, I'm a little bit excited because it's our pleasure to have you all here. So today we're going to talk about the Cype 3D architecture and most focus on Cype Connect with our latest updated version 2024. And in this seminar, we're going to introduce various tools that use timber as structural material. And you will have the opportunity to quickly understand the process of defining material characteristics, structural elements, load applications, result analysis, and also the generation of detailed documentation and drawings. So before beginning this webinar, everyone feel free to ask any questions in the chat during the session. We will reply you there, okay? And so I'll give the control to the Afonso.
All right. So yes, let's begin. If you could please confirm that you can see my screen from this moment. Could you see it?
Yes, perfect.
All right. And I think we can also turn off our cameras. Then we have more space on the screen to share the details of our presentation. Yeah, let me turn off mine. If you please could do the same, Jimin.
Yeah, I already did it. Yeah, you can begin with the presentation now.
Perfect. Okay, so yeah, let's begin. And I think here we have it, okay? All right, for this seminar, I've selected 7 combinations of different tools that we have in our ecosystem. I'll try to cover different steps or different phases that we can have in a project, okay? Since the beginning, when we are talking about 3D modeling or architectural modeling or BIM, build information modeling, then we'll jump to the structural analysis. Okay, so we'll design the timber structure. Then we'll go one step further and design the connections, like as you can see here in this image here. So the connections between two or different timber elements. And then we'll finish taking a look on the graphical documentation that we can extract from these models, and also a little bit of quantities or quantities to surveying, bill of quantities. Okay, so we will use this information to estimate the cost of the structure. Okay, so let me start with the first software. This is Cype Architecture. Okay, Cype Architecture, it's our 3D modeler or 3D BIM modeler. It's a software very easy to learn. You can do a lot of things here because the software have this 3D environment that you can use to model your building. So you can work also with like 2D sections and floor plans. You can create perspectives. Okay, actually, it's quite easy to work with this software. You can create this kind of cuts, okay, using this axis to access the information that is inside of the model. And here you can create your textures, your colors, your materials to then create a model that is, in this case, related to wooden structures or wooden building or timber building. Okay. In this case, for example, just to show you how I use it, the software, I've created here, for example, in the architecture tab, some colors that are the different colors that I will use to this model. So I've created here one color I created actually here 3 types of wood 1, 2, and 3. And for each one of these colors, I defined a color and texture. Okay, so here there is a library of textures that you can assign to your materials. And also I decided which materials would be available in my library here. I've then created here some types of elements: walls, columns, roofs, floor slabs, and each element I defined some properties trying to create these timber elements, or these timber walls in this case. So I have one here that is the external wall, 12 centimeters. Here you can see that this wall have some properties, some faces, face 1 and 2 with the material that I've showed before. Okay, so here I can select the other materials if we want. If we go to a different one, for example, these masonry walls, it's going to be different. So here you can create these types. So I've also created here some beams, okay, some slabs, for example. So here in the slabs, I created here some slabs with wooden materials here, okay, to then start modeling the building, creating the different vertical elements like the walls, the curtain. In this case, we don't have curtain walls, but the railings, the columns, okay. Also the horizontal elements like the floor slabs, suspended ceilings, and then I finish it introducing the windows, the openings, the doors, okay, to create this model here, okay. Just showing another element, another model created here. You can see this one here. It's a urban park element. It's a kind of portal. These frames, they are very popular today. We can see these frames in different parks around the world. So I've created this one here made by wood. And in this one, the software was used in a different workflow. In this case, I used just the sketch options that we have here in the software to create the geometry of these frames. Let me deactivate, for example, the structure here. These black lines that you see here, they are actually sketch lines that I've created using here the lines, quadrilaterals, polygonals, all the drawings tools that we have here in the sketch line, and then using the tools that we have here available in the BIMserver.center section, I shared this project to the cloud and used this geometry to then transform it in an analytical model to analyze this structure. And actually what you see here is the result. So it's the structure that was exported back from the structural analysis software to the cloud, and then here to Cype architecture, and now it's available here. Actually, here I also designed the connections here, so you can also see also the connections between these wooden elements. We'll see how we can do that in a while. Okay. Another example here of architectural modeling is this pavilion. Okay, this pavilion, it's something similar to the previous one. Here I used the sketch tab or the drawings tools to create the geometry of this pavilion. And as you can see here, we have a very nice roof with this geometry that is a little bit complex. It was created here. If I deactivate the structural model, here you can see then the other architectural elements that were introduced to complement and to close the structure, creating this pavilion. Okay, in this case, as I said before, I've just used these options here, exported to BIMserver.center, and then I've imported this geometry in a structural analysis software that we'll see in a moment, and then analyze it there and export it back to have these wooden elements here. Okay. And the last one that I would like to show you is this very simple one here. Actually, it's just it's a skate park, okay, made by plywood and some wooden elements. And I've used also the sketch tab to create the geometry of this skate park. And then using one tool that is very interesting that we have here, we can transform the geometry of the sketch elements that are created here to architectural elements. In this case, I transform it in some small pieces of plywood, okay? Because in this case, my intention was my intention was to estimate how many square meters of plywood I would have in this project. So the geometry was not so simple. So I modeled, and then I also exported this project to the cloud to then open in a second software to analyze these quantities. We'll see it in a while too. Okay. So as you can see, we can do a lot of things here at Cype architecture. Here, your imagination, it's the limit. So you can create your own materials, your colors, you can create buildings, you can create pavilions, you can create geometries that are complex like this, okay? Just showing here, if I deactivate the slabs, you also can see here the beams that are under the slabs, because it was important to me also to know how many meters of beams I would have in my project. So these beams were also modeled here the same way. I can transform sketch to architecture and have this nice geometry, okay? All right, so this is the first of the 7 tools that I would like to share with you today. Let's go to the second one. We have been talking a little bit about structural analysis. When we talk about structural analysis, we have 3 different tools here in our suite. I will start with this one. This one is called Cype. Maybe this is probably one of the most important parts of this webinar. This software allows us to create different type of models: reinforced concrete structures, steel structures, aluminum structures, and also wooden structures. Okay, so I've created this little model here just to show you as an example. Let me activate here the ground. So here actually we have a basement. It's a partial basement, okay? And then we have this structure created here at Cype, okay? Let's see some results here. For example, if I open this button here, I can see not just the wooden elements, but also some other details. Let's see what we have here. So here, for example, let's deactivate the ground. We can see also the rebars here of this basement wall, okay? And everything was calculated according to a specific code with some materials that were available in the library of the software, and then we can see all the results related to that, okay? Just showing some results here. For example, we can see the deformed shape of this structure. Let's take a look on that. So if we open here, for each load case that we have in our project, we can see this deformed shape. This one, I think it's for one of the wind cases in one specific direction. Actually, here we can also see how it works with this animation. That is quite nice to understand what is happening in this load case. Okay, if we change here the load case for, I don't know, self-weight, it's going to be different. Okay, these values, they are applied with a scaled factor. So 500, actually the real situations would be with a scale of 1. So let's put, for example, 10 to have an idea. With 10, we cannot see the difference. With 1, it's going to be impossible to see the difference here, okay? Here we can also see that this software, it have a different environment, okay? Here we work with floor plans, and we have these little buttons here to change from one floor to another. So here we have the basement, the first, the second, the third, and the fourth floor. And everything that we introduce here, then we can see in the 3D view by clicking in this button here. So here we are working in a hybrid environment. We introduce the elements in 2D, and then we can consult it in 3D, okay? Let me show you some interesting things that we can define here in the software that is related to timber structures, okay? Every time that we create a new project here, the first thing that we must set in the software is the general data, okay? And here in the general data, here, this is the core of the project. Here we define everything that is necessary to then analyze this structure, okay? So the first thing that we decide is the code that will be used to check if the structure is safe or not. According to the materials that we introduce in the structure, we have different codes. So concrete codes, code format, rolled steel, and timber. Okay, for timber we have these codes that you see in my screen now. I have been working with the Eurocode 5 for the European Union to that example that we saw before, although also there's the American code and other codes that are available here. Okay, so here we select the code, and according to the code, we will have a list of materials in the timber section in this case. Okay, so here we can select, in this case, it's the Eurocode is selected. So here we can see the materials according to the Eurocode. And for each part of the structure, the columns, the beams, the joists, 3D structures that can be imported from other softwares, we select what kind of wood in this case we'd like to introduce. Could be sawnwood, okay, coniferous and frondescent, and also glued laminated, homogeneous and combined, okay. And then, for example, if I select here the conifers, I can see the classes, the resistant classes according to the conifers, the popular conifers. If I go to glue laminated, I can see the different classes available in the software. Okay, so here we set basically here we set the materials, the timber materials. Then we select the service class. Okay, and also the duration of the loads introduced as live loads. We can select by selecting if it's permanent, long-term, medium, short-term, or instantaneous. Okay. Besides that, here we can also define the wind loading. Okay, so here I also selected the Eurocode, although there is a lot of codes available here, different countries. Okay, so here we define the reference speed, the parameters related to the geometry and the position of the building, so the different coefficients that the code suggests to us. And of course, that for each code that we select here, each flag of these codes that we have here will have a different properties here that we must fill and then analyze the structures, the wind, the effect of the wind in the structures. Okay. We have something similar to the seismic loading, and also we can check the fire resistance. Okay, and then we can also add additional load cases if we want. Okay, some specific load cases if it's necessary. Something nice here is the introduction of the elements. So we can introduce the columns in this first tab here. Let me show you here one of these columns. So for each one of the levels of the building, we can add a different section if we want. And here we can select the materials. Could be concrete, could be steel, could be this composite section, or timber. And in the timber section, we have round bars, squared bars, and also rectangular bars. Okay, so circular, solid here in squared, and laminated. Here we have a huge library of materials. So in this project, I have been working with laminated, a series of laminated sections, which the base is 220 millimeters. So in this series, we have 220 millimeters, and then the height is going to be different, okay, or the depth of the section. And here we can see the properties of the selected section. Something cool in this software is that you can define a first section. For example, let's imagine I start trying to design the structure with this section, and the software can then design it for us and choose the best section if the section that we selected is not enough. Okay. Here you can see that I just select this section, but the material is already assigned. So it's the material that we selected before in the general properties. But if we want to have a specific material here, a different material just for a specific element, we can check this little option here and change the parameters for a single bar or a single column in this case, because maybe we can have exception here, okay? In this case, I'll leave the material as the default that I've selected before. To define some bins, it's quite similar. The difference is that we jump from this tab to this one. So here we can see that we have here some bins, okay? So I've created these bins. Let's edit one of these bins just to show you here. So this bin, again, we just have to select a series and then a first section, and the software will design for us and choose the best one. It actually, they are the same sections that we saw before. Okay, they are available here. And we can also download more predefined sections that are available in the library of the software if we want. Okay. Another thing that is interesting here, it's related to the slabs. There is a specific type of slab that is made by joists, in this case wooden or timber joists. Okay, so we can create these elements. So by defining the geometry and the properties and the type of sections, we can define here this type of slabs, and it's quite easy to then design the structure with these slabs, because you just set these parameters here and select one of the panels here. So let me delete one of them. So I just have to come here, select in my library of slabs the slab that I want, and select the panel, and then select the direction of the joists parallel, for example, to this bin, and it's introduced. Now I just have to go to analyze, and the software will analyze for us if this selection was good or not. Okay. In this case, the software also select the best section to the joists. Okay, if it's possible, if there's a section available in the library. If it's not available, we must change the properties of this slab, trying to find a better option. Okay. So this is CypeCAD, the results tab. Actually, now I changed something. I must calculate again, but here in the results tab, you can see all the forces like the momentums, shear, axial forces. You can also see here the analytical model of the structure. You can see the different results in the columns, in the bins, okay? And when an element here it's not safe, it's going to be colored in red, so it's very easy to know when you have a problem and that you must solve here. Okay. As I said before, when we talk about design of timber structures, we have more solutions here at Cype, and one of them it's CypeCAD. The second one is called Cype 3D. Okay, Cype 3D. Let's jump to Cype 3D. Here we have some things that are common between CypeCAD and Cype 3D, and some things that are different. Okay, the first thing that we can see here in Cype 3D, it's that we have a 3D environment to work. It's the name of the software, Cype 3D. Okay, as you can see here, this analytical model that you see here, it's exactly the same model that was created here at Cype Architecture, as I said before. So if I deactivate the structure, these lines were exported and then were imported, here, okay? And then with this geometry, I could define the elements, the bars, all the conditions, the load cases, to then design this little structure here, okay? In this software, we also have a general data panel. Here we also select the codes as we saw before at Cype Architecture, at CypeCAD. Here we also have different codes, okay? The Eurocode 5, the American code, and here we also define the timber conditions or timber materials. Okay, also the same materials available here: glued, laminated, and saw. Okay, and once we define these parameters, we can then define the bars, selecting these elements or creating these elements. Okay, going to the library of sections, selecting the elements here, look, this is quite similar to CypeCAD. Here you can select probably the same bars that we have at CypeCAD. And there is one thing that is different here, that is this option here, because here we can also create not just constant rectangular bars, but also rectangular with variable depth. Okay, so here you can design, you define an initial and a final depth of the section. Okay, here when you create this this little element here, this little analytical model here, you can add the loads. So for example, here the loads, I've introduced some loads here. The self-weight is automatically generated, and then I introduced some extra loads to this little sculpture. Let's say that is a sculpture. And then you just have to click on analyze, and the software can design or not. You can select if the software will design or not the elements for you. Okay. When it's finished, if it's everything, it's green here in this option, so it means that it's safe. In this case, it's safe. And then we can see, for example, the deformed shape also here. Okay. Let's take a look. In this case, we can activate the structure to have an idea how it works. Okay. And then we can also see here the 3D view of the structure as we saw before. Of course, everything here can be exported. The drawings can be exported. All the documents, all the results. So here we have different kind of reports and different kind of drawings that you can generate. Of course, the software, it's also useful for steel structures and also some concrete elements. But as the focus of this webinar is timber structure, I am showing these examples that are timber elements. Okay. Another example that I have here at Cype 3D is this little pavilion. So this one. So this is the same that we saw here. Okay, the architectural model, and here we have the structural model. Here, if I go to the 3D view, I can have an idea about the structural model. Let's take a look. Here you can see they are integrated through BIMserver.center. So we have here a federated model. We can see one layer of information that is the structural model, one IFC file, and then a second layer that is the architectural model with these curtain walls, these roofs, these slabs that are complementing the model to create this federated model. So it's how we work here at Cype. Everything is connected to BIMserver.center. You always have a button or a menu to send and receive information to the cloud, and then exchange information with your colleagues or between two softwares that you are working in the same computer. Okay, so this is just a new another example. Let's see the format shape here, just to have an idea about how is that. Yeah, here we have this one. Let's look for a nice angle like this. Let's see what happens here. If we can see some, no, with this scale is not enough. Let's add more scale here. Now it's okay. Let's see what's happening here. Here we can see how the structure is working for this load case. Quite nice. Very easy to understand what is happening here. And then if it's necessary, change parameters, change sections, look for a better strategy to design the structure. Okay. All right, so let's keep going. So we saw this little example here. Okay, so we saw how we can use Cype 3D in a very, I know that is very fast, but here we saw that it's possible to design the structure here, but to design the connections between these elements, we must go to another software. Okay, so in the first element the first project that we saw, there was the structure itself, but also the joints, the connections here. Okay, so these connections, they were designed in this software here that is called Cype Connect. Okay, Cype Connect, as the name says, it's a software to design the connection between structural elements. We can design steel connection between steel elements and between wooden elements, and we can also mix both of them. For example, I could have one steel column and a wooden beam, no problem. Okay, then we'll see some examples. And the idea here is when you work here at Cype 3D, you export these elements to the cloud using this share button. Then you start a new project here at Cype Connect, import the structure. Okay, actually, if I change some parameters here, let me show you here. Here you can see the analytical model, exactly the same analytical model that we saw before at Cype Architecture, Cype 3D. Okay, and then for each node that we have here, actually each node that is in the model, it's represented by this pyramid here. It's also one element in this list. Okay, in each node we'll design a connection. Okay, for example, I'll take this guy here. This guy here, if I click here, I can open the connections editor. Okay, so this element here was created with different operations. Okay, so we can define these operations by using these options here, and according to the operations that we do, we model the the connection. Okay, so in the beginning, the node was just like this. Then I started adding here some operations to define the ground, adjust this element, add a first plate, then round the plate corners, add a second plate that is inside of the 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 the, the wooden element. I then changed some parameters of the plate, I add a weld, then some bolts, okay, some concrete elements to then add the anchors here inside of the concrete element. Here at Cype Connect, we have a specific option that is this one here that's called timber, where we can find dowels, bolts, and screws. So this is an exclusive tool that we have here just at Cype Connect. There's a second software that is called Strubing Steel. If you are working with Strubing Steel to design steel structures, at Strubing Steel, you will not find this option here. Okay, this option is available just at Cype Connect. So the workflow to work with wooden structures is connecting Cype 3D or CypeCAD to Cype Connect directly without using Strubing Steel, because this option is available just here at Cype Connect. Okay, so once you have the model here, then you can analyze it. Actually, in this case, the forces are too small, so I will probably have no problems here. So let's analyze it. So these loads, both load cases and loads can be imported from the model that was analyzed before at Cype 3D or CypeCAD. And as you can see, everything here is on green, so perfect, no problem. The loads were too small. Here we can see the von Mises stress in the plates. We can see here these places that we have a little bit more. We can also change here some parameters just to see a little bit more this distribution of stress here. We can also see the equivalent von Mises deformation and the displacements. Okay, and if if we have a situation that some checks were failed, we'll see this part, this reports here in the red color. Let me show you one example here where the columns are, for example, this guy here, probably it's not safe. Let's take a look on that. This one here. No, here we can see that it's not safe. Although here it's everything green, we have some problems here. So if I check this element, I can see that according to the code that I've selected, there are some distance of the bolts that are not okay. Probably is this bolt here, although they have enough resistance, the position of this bolt is too probably is too near to the other plate. So yeah, the software check also this kind of parameters. It's not just the maximum demand capacity radio or the stresses, is also these other parameters that are sometimes very complicated to check manually. So the software tells to us this kind of results too. Okay, so the solution here would be probably change the position of the bolts to try to have numbers according to these limits established in this specific point of the code. Okay. At Cype Connect, we have also different codes. So if I go here in this general data menu, we have here these two codes and then a specific section to the codes to the timber. Okay. So here we have the Euro code. And also for the concrete element, we have here different codes. Okay, so here still we have a little bit more. Timber, we have the Euro code, and the concrete anchors, we have here two codes available. Okay. Something cool that we can do with Cype Connect, besides analyzing the structure, modeling the structure, is to have the drawings of these codes, these connections. Okay, so if I select, for example, this guy here, let's go there. So we saw the model tab, we have the analysis tab, but we also have the sheets tab. Okay, and here the sheets tab, we are working with a paper. Actually, I'll delete this one and start a new one, just show you how easy it is to create a document with this element. So I'll just add a new sheet. I'll select here, for example, a size, A2 landscape. It's going to be here empty. And by using this element, this tool here, I can use this magic button to insert here some parts of some views of my model. Okay, so I define here some parameters related to the style of the texts, which views I would like to introduce, the scale of each view. Okay, and then I accept, and the software will generate these elements for us based on the model that was created and checked before. Okay, that's important because we have a model that we have created the model itself, we check it according to the Euro code in this case, and now we are creating the drawings automatically from the model. Okay, so if we come back and change the model, then here we can come here and update it. It's going to be everything connected, so you don't have to change anything here manually. Okay, actually here it was generated in two sheets. It was not enough one sheet. Okay, and here you can see that these elements were generated automatically, some of them with the dimensions. And there are a lot of things that are very nice to do here. For example, the tags, they are very interesting. If I click in something here, for example, in these boats, I can take the information from these boats. I can change these informations here. Or if I take, for example, from this, let's create one more. For example, let's take this plate here. Or I took the wooden element. So with these tags, you can easily get information from the model. So this information, it's automatic. Although you can also enter here and change these values and add your own text if you wanna create something special. So then you can change this information. Okay. There are different ways to represent these sheets with color, monochrome, vector, hybrid. You can also set a printing color that is different from the identification color that you have in your screen. So in this case, the printing color is going to be everything black, or black and gray maybe. Okay, something like this. And actually each one of these elements, it's a kind of viewport where you can change the scale, you can change the actually move this because the connection is here, and then you can set the parameters of resolution, background, the frame of this viewport or this scene that was generated. You can also move these scenes to another part of the sheet. Okay, you can also delete part of the elements if you want. Okay, and then when you finish, you have a list of sheets. You can export it, print it to different formats like DWG, PDF, DXF, and save it in your computer. Okay, if we're talking about drawings or graphical documentation, there's another software that is called OpenBIM Layout. That is this one here. Okay, OpenBIM Layout, it's a software that have some common tools with this tab, the Sheets tab that we saw in at Cype Connect. So in OpenBIM Layout, we can use the update button to synchronize and import different IFCs, different layers of your federated model, and then combine it to create also sheets like this. So in this case, I combined the joints from Cype Connect, the structure from Cype 3D, and this architectural model that is the trees and this other part that came from Cype architecture. So here we can see different combinations. Here you can create your own documents. You can add the logo of your company. And something nice that is you can import the connections that you've created at Cype Connect, for example, here. And then in the end, you can create different folders or different sections of your project and manage all the sheets of your project here to then export everything together, everything with the same information. You can add also the pages and use the information from the document. So it's a good tool to manage the graphical documentation of your project. Sometimes you have just structural elements, but sometimes you can have also other disciplines. So here you can merge these elements to create your documents. Okay, so this software is actually for free, OpenBIM Layout. You just have to download it and start importing IFCs from other softwares. Here you can also import IFCs that are not created with software developed by Cype. So if you work with Autodesk Revit or ArchiCAD or any other software that exports IFC, you can import these IFCs here at OpenBIM Layout and merge it and create your documents. Okay. Let me see. Here I have just another example. That building, that little house that we saw in the beginning. Here I created some other floor plans, some other sheets here. In this case, it's an architectural project. Okay, so some of them are colored, some of them are black and white, monochrome. Okay, let's see how is the result of this same section, the same floor plan vectorized. Take a look on here we have it. So let's see what we have here. We have here some sections, some another section here, some elevations, nice elevations. This elevation that I called elevation on X-ray because I filtered part of the model, adding some transparencies to the walls, if I remember. Here we have it, okay, and so on. So here you can create all the sheets of your project, okay. The last one that I would like to show you, it's the example that I said before, that is this skate park, okay. So let's try to quantify the surface of plywood. So I have two types of plywood here. I have the plywood with this first color that is here and here, and then the brown one that is here. Okay, and then I also have the beams or these structural elements that are under the plywood. Okay, that is here. Of course, this structure need more elements, but it was just to show you how a complex model like this could be easily quantified using our tools. Okay, to do that, I use OpenBeam Quantities. OpenBeam Quantities is this software that we have here in the screen, this purple software here. So with this software, you can import IFCs here, could be more than one IFC, and then you can establish some rules to select elements here in the project. Okay, so when I've created this architectural model here, I created some types, and here in the, for example, in the floor slabs, I created 2 types of plywood, and I know these names here. Okay, and knowing these names, I can go to the second software and filter, creating some sets of measurement rules where I can select everything from the project that have this name, and then add items from a cost database to that element. Okay, so I did it, and now I can know the areas, for example, of these these elements. In this case, I have here 3 things. I have, let's open a little bit more. I have here the 2 layers of plywood, 12 millimeters, color 1. Okay, that I have 575 square meters that is selected on orange in our model now. Okay, so it's something like that. Then I have here 224 of color 2, that is just the flat surfaces, the bottom and the top. Okay, and then I have here almost 600 meters length of wooden elements of 5 per 10 centimeters that are these little structural elements that you can see here. Okay, if I click in one of these elements, actually here it's going to be a huge list of a lot of elements that each piece of these elements, each piece of this structure, that I can see exactly the size. In this case, I have here this element with 2.96 meters. Okay, that's going to be different from this little piece here that's going to be just 0.15. Okay, so as you can see, it's a huge list, and the total amount, it's going to be like almost 600 meters of bars. Then I can apply a cost for that. Let's imagine it's 7 euros. So here I have the total cost of 4,000, almost 200 euros just for the wooden elements. And the total until this moment, the total that was modeled, it's around 32,000 euros. And I can see that the item 1, it's more expensive. So the plywood color 1, it's more expensive than item 2 and then item 3. Okay, of course we can keep creating more elements. We can define all the parameters related to these costs, like all the materials, the laborers. We can add the machinery. We can add more elements to our BIM model. But this was just a very simple example to show you how you can have a complex model, a complex surface in this case, and then with just some steps, you can have a precise quantity to then estimate the cost of your building. Okay, Jimin, I think that's enough for today. I think we can finish our presentation here. What do you think about this topic?
Great. Can you hear me now? I just turned on my camera.
Yeah, I can hear you. Yeah.
Yes, great.
So,
And this is I think it's quite like impressive. It's really good like presentation. Thank you very much for this. And I want to ask you guys, do you have any like further questions about the workflows, the features, or how to use it? Any questions you have, you can send them in the chat. And if you don't get a reply from us, you can send us an email or leave your email here too. Our team will get you back as soon as possible. At the end of this webinar, thank you all for joining us today. Actually, we have a limited offer for our anniversary this month. So if you want to try some personal demo or grab some trial license before you decide to buy or get any quotations, feel free to get in touch with us whenever you feel like. And I think that's all for today, right? So here to have a nice day to everyone. Bye, guys.
Thank you very
Bye,
much. See you.
Alfonso.
Thank you, Jimin. See you in a next opportunity. Bye-bye.
Bye.